Hello and welcome everyone to this new video in our series about generative AI. In this video, we will be making an IntelliJ IDEA plugin which will use Ollama and offer an AI assistant for you when you are writing Java code using the JetBrains IDE IntelliJ IDEA. So I will show you quickly how to set up a plugin project. Then I will show you some of the options which I tried. So I started by trying to run the LLM inside the plugin. And for that, we already now know two options. So the first option is using llama3.java, which we used in a previous video. And the second option is llama.cpp, which we also have used in the previous video. For llama.cpp, there are Java binding, which you can find at GitHub, which you can also use in Gradle build file without even needing to go to GitHub. I tried both these options. Unfortunately, after loading the model, the plugin has crashed. I was not able to find the reason. I assume it's because of the memory. So I wanted to quickly finish the plugin. That's why I fall back to the option of using the Ollama 4G. So Ollama 4G is the Java library which enable us to communicate with Ollama. So now we will be running the LLM on Ollama, similar to what we've did for the plugin for VS Code. And then we will be using this library to generate functions or auto-completion. So I will be implementing two features in this plugin. So one feature is function completion, and function completion I will be implementing as an action. The second feature will be auto completion, and auto completion will be implemented as completion contributor. So let's go to the code. So as you can see, I already created the project, and for that I only needed to install IntelliJ IDEA plugin. So let me show you the steps here. So you go to the JetBrains website and download and install IntelliJ IDEA. I'm using here the community edition, and then we need to go to the marketplace from inside IntelliJ IDEA and install the dev kit. So this is the website to the dev kit, but you don't need to go to the website. So dev kit is a plugin, and that can be installed if we went here to settings, and in settings there is plugins here, and here you can see all the plugins. And you can see here the marketplace. And now we can write, for example, dev kit. So as you can see, it's already installed for me. If it's not installed, you will have a button here like this one, install, and you can click on install, and that's it. So after installing this dev kit, you maybe need to restart your IntelliJ IDEA IDE, and then you can come to here to new project. And if your installation is successful, you will get an option here called IDE plugin. So as you can see, this is the settings which I used to creating my project. And here you can put the name of the project. So I'm using the name Starlight Llama, and then you can put here the group, the artifact name, and of course which JDK you want to use. So for me, I'm using the Eclipse JDK 21, as you can see here, and then you click create. I will not click on that because as you can see, the project is already created. So when you create the project, IntelliJ IDEA will create most of these folders here for you. So if you worked with IntelliJ IDEA or with Android Studio, then this structure is not new for you. So here you can see the Gradle files. We don't need to touch those. The IDE files also, we don't need to touch them. The .run and build. So here we will get our classes and other build artifacts. And here inside this folder, we have the Gradle wrapper. So all these folders here, we don't need to touch. Then we have the source folder. Here we will be putting our Java sources or Kotlin if you are using Kotlin, and of course resources if resources are needed, like icons or other resource files. Then there's the git ignore and the build.gradle. So I'm using gradle.kts in this project. So if you click on it, so this is an important file. Here is the settings for our project. So this file will be created automatically for us. What we will be changing mostly is this dependencies section. So as I mentioned in the introduction, so if you want to use, for example, the llama.cpp binding from Kroot, so you need to add this dependency here. And if you want to use Ollama 4G, so we are actually using Ollama 4G, so you need to add this dependency here. So actually this dependency is not needed, so I can comment it. I tested it, but I'm not using it. And then here inside these tasks, you can put the different options for running. So if you remember, when we run llama.java, we have to add here some options to enable preview and use the vector library. And so the rest of the files here is also for the Gradle. As you can see, we will not be touching those files. And then I have this small help file where I'm putting the steps which I'm using and the websites. So I will keep it. And then the external dependencies here. So that's it. Let's go now to the code. In the source main, we have the Java, Kotlin, and resources. So I am not using Kotlin now. As you can see, it's empty. In the resources, you will have two files created for you. So the plugin.xml. In this file, we will be configuring our plugin. So this file is very much similar to what we've seen in VS Code, where we need to add the contributions of our plugin. So our plugin here will contribute two features. So the first one is a completion contributor. So that's why I added this line here. where I'm saying, okay, I have a completion contributor and giving it an ID and then putting the language and the class which will implement this contributor. So we'll go through this class later, yeah. And then we also have here a section for actions, and inside this actions, as you can see, I added one action, and this action need to have an ID. So I put this ID here. Then the class which implementing this action, I'm calling the class, as you can see, and the ID is generate function because I will use this action to generate a function. So actions here are similar to commands in VS Code, and I'm giving it also a name. Then I'm telling it where to put this action. So I'm telling it to put it in the tools menu. So this is the menus here, and we have the tools here. That means when we run the plugin, a generate function icon will appear here somewhere. And this somewhere should be very close to the top because I'm putting the anchor to be first. But of course, maybe other plugins is saying first. So that will also depend on other plugins which you are installed on your IDE. And then I'm adding the keyboard shortcut. So we have the first stroke, Control Alt G, and the second stroke G. So I will press Control Alt and then GG. That's how I will do it. Maybe we can install a plugin for that. So let's go to settings. And in the plugin section, I think the plugin called something like Presentation Assistant. I think it has been added to the IDE by default in the new versions. So let me put it here. Also here we have the Presentation Assistant. As you can see, we don't need to install it as a plugin. So we need only to click here, I think, and say apply. And now let me try a key. You can see the pop-up here. It says save document. Let's try Control Alt G. So it's actually give the action name. So let me update the display time to 2 seconds and the position to top left. So it will appear at this corner here. And let's click OK. And as you can see, we start getting the tooltip here, the presentation here. And now we start getting the action here, as you can see. And we can click here and change the settings, as you can see. Yeah, so let's go now to the source code. So I will expand all the files. That's not too much, don't worry. So we have the llama.cpp model. So this model is not used. So I tried to run first using the llama.java and it crashed after loading the model. And then I tried using the llama.cpp and now we are using this binding here, as you can see from Kirud. That also did not work, but since I did not have any video about using llama.cpp in Java, I decided to keep this file here in case you want to try that. So as you can see, there's an init function. You need to call this init for this class. So you create a llama cpp model instance and then you init it. To use it, you call this generate function and pass the string which you want to create. As you can see here, we have the prompt, create a function in the Java programming language 2, and the line can be something, add 2 integers. Then you can see here we are putting inference parameters and calling the generate function. So I will just comment this file here. So since it's not used, let me close it. Then I would like to go to this utils folder. It has only one util files, and this util file contains functions for the editor. As you can see here, this file depends a lot on the Open API from IntelliJ, and it contains functions, for example, to recognize the current language, to get the text before the cursor and after the cursor. And I have two variants of this function. So first one, take as an input an action event. So this can be called from inside an action event. And the second one, take an editor as an input. And then there's a function to get the current line of text. So for example, if my cursor is here, then it will return this line here, the whole line. And then we have add text to editor and add text to editor end of line. So as you can see, similar to the function which I had in VS Code, we really don't need to go in details in these functions because all of them use specialized classes from IntelliJ IDEA. As you can see here, for example, document and editor and create model and so on. And the class settings is actually very simple. It only contains for now few parameters, and as you can see, they are not used. So those parameters I was using in the llama.cpp or llama.java when I was trying to run a gguf. Now I am not using them, so we actually can comment also this file. Then let's go now to the Ollama 4G model. And here we are calling our Ollama. And as you can see, so we first need the host, and this is the default port and localhost, as you can see. Then we have the Ollama API instance. I called it model here. In the init, we just create a new instance from that. And then we have two functions, so one to generate a function and one to complete a code. So for generating the function, we need a line of code. So for example, add 2 integers, as you know. Then we will add it to this prompt. create a function in the Java programming language to, let's say, add two integers, and then we are calling model.generate, and we are using the code llama with 7 billion parameters. Here we should have the current prompt, and then we are passing the current prompt, and we are not using a raw input and output. That means we are taking care of the template, and then we have some options here, as you can see. So temperature to 0, that's the only one used. And then in this line, we take the results, which we get from the generate, and get the response. And that's it, basically. In the code completion, it's something similar. So we have a current prompt, complete the following code, and then this input text here would be the code, the position of the caret, and we call the generate function similar as before here again, and we return the response. So the only difference to the previous function is the current prompt for now. And here I'm implementing a singleton, so I will only create one instance from this Ollama 4G model, and I will get it always using this inst. So that's it for this Ollama 4G. Now what's left is to go through this generate function and this completion contributor files. So for generating the function, as I mentioned in the introduction, we are implementing an action. So as you can see here, we called our new action generate function, and it extends an action. And for that, we need to implement this action performed function, and this function take an action event. So there's a lot of commented code here because, as I said, I was experimenting with two other kinds of libraries, namely llama.java and llama.cpp. So I will remove it for now. So you can see the code is really simple. We need to get the current line of code, then we call the generate function on the current line of code, and we add the text to the editor. So really 3 lines of code now. And for the completion contributor, so here we are extending the completion contributor, and inside the constructor we are calling this function extend, which will take the type of the completion. So we are using the type basic. I think there are another one type or so. Then the element which we are using that for, so I'm using also PSI element, and then we have the function which will run for auto completion, and this would be the function. So we are getting the text before, then we need to generate some suggestions, and for that we are calling the Ollama 4G model instant and the code completion function. So this code completion function, and we pass the text before as an input. Then this function here will return for us the completion. So now here the code from this replace till here is only trying to remove the unnecessary parts from the response of the Ollama. So this first part here is trying to remove the input, so we are just replacing the input with nothing, because I've noticed sometimes that the code llama is returning the text before and then the completion, and then if you put this as a completion option, you will get the text before twice. So that's why this replace here. Then I also noticed that sometimes the code llama is returning the code inside these 3 single quotes here, so I need to remove them. So that's why we have this code here. And finally, I'm also trying to replace the user input with nothing if we cut it. Now for me, for code llama, this have worked. So after this text manipulation, I get only the completion without any extra noise. But maybe if you change the model to DeepSeek or something else, you need to look what you are getting and then change these response manipulations here. So now we are done. So we have our suggestion. We need to add it to the result. So the result is an input for this function, as you can see here. So we have result.add element, and we are creating an element from this text suggestions. And that's it basically for completion. So this is really the whole code for the plugin. As you can see, it's really small compared to our plugin for VS Code. So let's test it. For that, we only need to run. So since we are testing a plugin, when we run, we will get a new instance from IntelliJ IDEA with the plugin installed. So this is the new instance from IntelliJ IDEA, and I already created a test project here. So you can see a small untitled project for Java. Now here, since the plugin is installed, we can go to tools, and you can see we have the generate function, which has Control Alt G and the second click for G. So let's try to test this generate function. So we need to put the caret in the line of code which we need to use to generate the function. So here I have a line, add 2 integers and return the sum. So we can go to tools and click generate function. So you can see we got again these 3 quotations. So let me go and also add this text extraction after the function generation. So I will put it in a function, and let me put it inside a util file. I will call it string util. So I will call it like remove llama formatting, and we'll take a string as an input. and we need also the input. So that's it for this function. Now let me put it here for the code completion, and then here for generate function, and let's rerun. And now let's generate the function by clicking this generate function here from tools. And as you can see here, we have now a public static function which will add two integers and return the sum. So let's now generate from this line here, multiply two integers. And for that, I will be using the shortcut. So I will press Ctrl Alt G and G. Unfortunately, the presentation assistant did not show the keys which I pressed, but we got the function here correctly, as you can see. Now let's test the second feature, which is code completion. So similar to how I tested the VS Code, I will delete these two lines here. Now I will press Control space. So this is the shortcut for code completion here in IntelliJ IDEA, and give it a second. Then you will get the suggestions. As you can see, there are many suggestions here. So one to use multiply, one to use add integer, and then here we have the suggestions from our code llama. So let me use it, and you can see it's suggesting to add the two lines and then print the output, which is a good suggestion, I would say. However, it's also added these two brackets here, which are now extra since we already have a bracket for the main and a bracket here at the end for the class. So let me remove these two brackets. Yeah, and that's it for this plugin. Before I close this video, I wanted to show you the other possibilities to extend these plugins. So for that, I have a link here, how to prompt code llama. So let me open this link. So you can see here the different options to prompt the code llama. So first you have the instruct, then you can do also code review if you want. So for example here, where is the bug in this code? And then you give it the code. You can also ask it to generate unit tests. And you can see it's also trained to return these three single quotes here at the beginning and again here at the end. You can also do an infill, which I think would have been much better than using just auto completion. So basically here you pass the text before and text after and you get an infill. Yeah, that's it. If you're really using Java and you want to extend this plugin, you can go to this web page here and try to add more features to this plugin, and then you can write to me in the comments about it. So that's it for this video. I hope to see you in the next one, and I hope to see really comments from you that you are extending these plugins. Bye.